Over the years, I have written lots and lots of terrible R code. Thankfully, I got better as time progressed, so in today's video I want to share with you a whole bunch of things that I have learned throughout the years. Let's look at, I believe, 12 examples of bad code I wrote and how I improved it to be easier to read or more maintainable or just in general nicer to work with. So that's what we're going to do today. Let's dive in. So the first thing we're going to talk about is kind of the mother of all mistakes. It's such a common thing to do this, even though it's not a good practice, that there have been lots of talks about this. For this, I've brought to you a little dummy script that does nothing but print the number pi. It modifies the options of how many digits we want to see, and then it does the thing that we want to avoid doing. Namely, it tries to reset the session. Or at least that's what a lot of people think if they put this ominous command at the top of their R script. Whenever I see clients doing that, I try to explain to them that this is not actually resetting the session or not giving them a blank slate to start out with inside of R, and they are often surprised by that. So this is why I'm mentioning this here. And we'll see that this actually doesn't reset everything to the way it used to, because when we then print pi, we'll see that it looks different. Let's source this whole thing, and now if we execute this, we see that, okay, in the first instance, the first line we've printed pi, which has these many digits, and then later on we've set the options digits to 10. Then we try to reset stuff, but printing pi then still prints the number with way more digits. And in fact, now if I re-execute this code, I can do as many times as I want to do that. It will always use these 10 digits because that was set as an option. So clearly, using this command doesn't give you a clean slate to work with. Instead, it just removes variables that you have assigned earlier. But in most cases, that's usually not what you want. So how do we solve this? If you really want to reset your session and want to make sure that when you run a script, everything starts from a clean slate, then simply make sure that you start from a clean session. You can do so really easily by using the restart console. And then you'll see that R has restarted. And now if I source the script, then there is my initial set of results again. So in fact, we can just get rid of this line. And if we want to make sure that everything starts fresh, we just restart. And then there you go. You have a little bit easier code and you don't actually have something in there which does something else than what you think it does. Next, let us try to import some data. Let's call this variable data and fill it using the read CSV function from the reader package, and then we need to specify a path to some CSV file. Inside of my Explorer, you can see here that I have a file called file.csv inside of my rsynth directory, which I'm currently using for this recording here. So a very common but not very good thing to do is to specify the full path to the file. So we have the YouTube videos directory that I'm currently working in. You have the directory that you've just seen here inside of my Explorer, and then it's the data directory and then the file name. And all of this is preceded by the full path to this directory. And this works. If I execute this, you'll see that code worked and we have imported this little CSV file. But this isn't a nice thing to do because this path here only works on my computer. It even specifies my home directory. So if I were to give this code to a colleague, he or she won't be able to work with this without having to adjust this. And you might think, okay, I guess my colleague can just adapt this path to whatever works on his or her machine. But a very cool thing would be if your colleague could just take your code and it just works. I know this would be really cool. Why don't we try to strive for that? And the way to do that is to work with projects. So I already told you I'm in my YouTube videos project, so I can just get rid of everything up till this directory and then use relative paths from there. And now if I execute this, the exact same code works. And if someone were to take this whole YouTube videos directory, just possibly from some Git repository, this code would work. And inside of Positron, you can switch between directories by simply opening folders and then this sort of code works. If you want to be even more careful, you could use the here command from the here package that really takes this relative path here and makes a full path out of it that we've just seen. That way you kind of have an extra layer of safety so that paths definitely work. And I know for this tip and the previous tip I've shown you solutions inside of Positron, but you can do similar things in RStudio as well. For the projects, you could just create a new project using this new project menu that you can see at the top right corner. And for restarting your R session, you could just click on the session menu and then simply restart R, and then you'll have done the exact same thing as in Positron. So whatever IDE you use, whether that's Positron or R, nothing is stopping you from using nicer practices. Next, let us talk about naming conventions. Naming things can be really hard, but it is often time well spent. A very common thing I did previously was to name all of my data sets just df as data frame. And then I would constantly override this variable like we see here. This is kind of nice when you're writing the code, as you don't spend any time thinking about names and you just use this short little abbreviation df. But when you write lots of code like this and then look into your code a couple of months later, you will have no clue what df means at any point in time. It's much nicer, or at least I think it is, if we use descriptive name to know what we mean by a data set. So in my case, I just named this df cars so that I know it's a data frame with cars in it. Then I can, in the first instance, filter this, and possibly I might name this df high mpg cars, because here we have filtered that have high value for the mpg column. And then we could also take this data set and filter for 4 cylinders. So we could do here df efficient 4 cylinder, or maybe instead of efficient, let's do high mpg 4 cylinders. So here it was just an idea of how to name things. You could possibly spend some time on naming conventions that work for you. But my point here is that you might want to actually spend some time on naming. In kind of the same spirit, this is probably not a good idea to hard code a lot of values. For example, in this filter call here, I have used a lot of magic numbers. That's somewhat fine in a data analysis if we know that these are some thresholds that business just gives us. But what I personally prefer to do is to not have these things inside of the filter call itself. Because if I look at this in a couple of months, I'll look at these numbers and think, okay, what does this even mean? So what I'll often do instead is I'll save the filter conditions into a variable that I name sort of meaningfully. So here I could write something like is efficient car, and then I just stick in these conditions here. And then of course, since this happens outside of the filter function, I need to make sure that the variables are available. But if I do that, then if I execute this, then I have a vector of trues and falses according to the number of rows of my data set. And then I can use these trues and falses inside of my filter function, and then everything works. Probably we also want to have this as a tibble for nicer formatting. So now everything looks kind of better. So now I could inspect my code a couple of months later and see this. Okay, I filter here for is efficient car. And then I understand, okay, I'm guessing there are some values for efficiency here. And that's why we have defined it like this. I can still work on the code without understanding these numbers here now. And if I wanted to go even further, I could save these numbers into a different script that I call constants and then just load them. But in lots of data analysis, that's probably overblown, so I'll just leave it like that. Next, let us talk about global variables. This is kind of a topic I have hard feelings about. In one sense, global variables are kind of convenient, but they make it way too easy to write bad functions that are not self-contained. For example, here I have a variable that I call threshold, and then I define a function that I call bad function, where it depends on one argument, and then for this argument it's checked whether it is larger than some threshold, but this threshold is never an argument of this function. Instead it uses this global variable. And now if I execute this and use this, we see that it works, because inside of my R session it really works, because there is a global variable and therefore this threshold thing is always defined, and this is why the function works. This is kind of nice and it makes it easy to write code very fast. But what bothers me about this is that I cannot take this function here, stick it into some script and then use it in some other project, because in some other project this global variable threshold might not be available. So this is kind of antithetical to what functions are supposed to do for me. They are supposed to be reusable components that I can use wherever I please, and it shouldn't depend on some global state that I may or may not know. So that's why I try to avoid this. So in this case, to make this a good function, I'd simply make sure that the threshold is also part of the function. And now I also have to call this function with the corresponding threshold. Let's call good function instead of bad function. And then if I execute this, everything works again. But now I could take this function and bring that into some other project because I know it is self-contained and it works without some other stuff that might or might not be defined. But there's some downside to this. If you set up your functions that way, you can end up with functions with loads and loads of arguments, which can also be really tedious. If you use that function very often, then you'll also have to set these arguments all over again. That's kind of annoying. But there is a way to mitigate that. And to show you what I mean, I have an example here. It's a function that calculates some prices based on base price, tax rate, discount percent, and whatnot. There are a whole bunch of arguments, and at the end of the day, if you just call this function, it gives you a dollar amount. That's basically what it does. And if you want to use this function all over again, then you might have to duplicate all of these arguments. And then if you adjust the function later on and have another argument in here, then you'll have to also add a new argument in each of the function call, which is really tedious. A nice way to avoid that is to create objects that bundle all of the information necessary for the function together. For that, we can use S7 classes. We can access them if we call the S7 package, and then we can define an object depending on different properties. So what we could do is to create an object called price configuration. It is a new class. This new class function comes from the S7 package, and then we name this new class, usually name it exactly like you named a variable, and then you specify properties via a list of things, and this serves basically as a blueprint for these price configuration objects. And in our case, that would correspond to tax rate, discount percent, shipping costs, and so on. And we could just define them as always being simple numeric numbers. And for other arguments like the currency symbol, we could say we need a character argument here. So let's stick in a class character into this configuration. And now what we could do is to create an object using this price config function we've just defined. So here you'd see that it is just basically of the things we have defined here. But the nice thing now is that things are enforced, so we cannot create a configuration without the currency symbol. Even if we don't specify it, we'll see that there is a placeholder for this. We could also throw in validations to make sure that something is specified, but that's a story for a different time. Let me just show you how to refactor this function here. Let's just duplicate this. Let's just leave the name as is, but we can use, instead of all of these arguments, we can simply say, okay, it will get a config. And then here we see that, okay, all of these things are not defined. So let's access them from our config. And we see here in our config, there's always this add symbol. And this is how you access stuff with S7 objects. You simply use an add symbol, and then you repeat the same thing for all the other arguments. And now you can just use the calculate price function using a base price and the standard configuration. So we execute all of this now. We see the currency symbol isn't found because we forgot to access the currency symbol here. And now if we do, we see that our function works again, but it has a much simpler signature. So now if we adjust our function and think, okay, our calculate price needs a new parameter, we could just update this price configuration and use it inside of here. And then all of our repeated function calls, say we have this like 5 times in here, they all still work, and we don't have to adjust anything here because we only need to adjust this one standard config object and the function that uses it. So that's kind of the magic of how S7 objects help you to simplify your functions. And it's also a nice way to bundle things together that are supposed to stay together. So now that we have learned how to make functions better, let's make them even better. Let's talk about the philosophy of how large a function should be. In general, I try to make functions so that they do only one thing, but they do this one thing very well. That's kind of the philosophy I try to strive for. It's not always something I achieve. Sometimes my functions tend to get too large, but in principle, I try to stick to this rule. And here we have an example that doesn't follow this rule. It tries to do everything. It tries to clean a data set, it computes summary statistics, It plots something, it fits a model, it predicts stuff using this linear model, and then it returns a whole bunch of stuff. So that's a function that isn't very nice to maintain because it has so many different things it juggles. So let's break this up into separate functions. What we could do here is to create a function that just does the data cleaning. So here let's call it clean data. Then we can do this model fitting somewhere else. Let's call this function fit model in yet another function. And then for the predictions, we could also do the same thing. In all of these instances, in this kind of contrived example, each function is only one line, but typically you'll have some little pre-processing or some other steps you'll have to do before you can do the last step. So that's why here it really looks very small and kind of like overblown to stick one line into one separate function. But in a real world example, you often want to have these little functions so that you have small self-contained units. And then instead of calling this analyze everything function, create this data set here. It's just a made up data set. And if we actually source this whole thing, we can see here a plot was generated. There's the plot. Not very pretty, but that's what we have. And then we have all of these things that are calculated here. So instead of having that calculated in one go, let's use our little small functions. So we could simply take our original data set and then pass it to the clean data function. And let's call this df cleaned. So of course we have to source these functions so that they are available. And now we have our clean data set. In this case, one might even like to think of a nicer name rather than clean data because it's quite generic, but let's just leave this for now. We could now take this df cleaned and pass it to the fit model function, and that way we'd have a linear model, and we could pass this to the make predictions function and use the data df cleaned for that, and there we have our predictions. If we wanted to plot things, we could just use the original command that we have here. So using this df cleaned data set, there is our ugly plot again. So I think you get the point here that we want to avoid having these large monolithic functions, but instead having small encapsulated functions that just do one thing. My typical approach is to start out writing something like this, and at some point I realized, okay, this is getting too large. Let's break this up and let's refactor this. Next, let us talk about nested if-else statements. I used to write code that looked somewhat like this. You have a chain of a whole lot of if-else statements. And in this case, this just gives me a color depending on what category I pass into this function. Now, what might be nicer code is to first get rid of all of the else statements here. So in general, I try to avoid having else statements here because they are not really necessary. I could write code like this, and it is much easier to read because then I can just figure out, okay, if category A, do this, and then I move on. I don't have to keep in mind with the else statements what came before that. So that's why I often just have if statements here, but even in this case, there are a whole bunch of if statements and there's a whole lot of repetitive code. A nicer pattern here to use is to simply create a dictionary of sorts that maps categories to the color that we want to return, or in general to the thing that we want to return. It doesn't need to be a color string, could be whatever. So what I do here is to create a color map that is simply a named vector. So if we look into this, we see here that we have names inside of our vector, and each name corresponds to one color. So that way we could simply get rid of this thing here and say, let's take the color map and access the category via its name. And then let's call this potential color. And then we return this thing. So now if we have this here, we see now that we get the colors back, but we have the name now returned as well. We can avoid this by using unname here. And then we're back where we started, that the function simply returns the color name that we are looking for. But what happens if we do category D that isn't defined? We'll see that we get an NA. And in this case, we can simply do an if else in here. If is not NA potential color, then we return potential color, and otherwise we'll simply return gray. And of course we need parentheses here. And now if we execute this, we see that for non-defined categories, we get gray back. And in the other case, we get back the color that we have defined in our color mapping here. So that was a nice trick to avoid having to copy all over these if-else statements It's just a refactoring of making your code a little bit shorter, more concise, a little bit nicer. Another area where you can make your life a lot easier is when you assemble strings. For example, let's take a look at this example here. We have a couple of variables, name, age, and city, and then we might create a greeting here. We can do so using the paste argument that just pastes things together. So if we do that, we see here that, well, there is our greeting. But this code here is kind of annoying to write. I actually try to avoid this at all costs. And a much nicer way to do the exact same thing is to use from the glue package the glue function, where we can just take this string template and then replace all of the values there with the variable by putting them into curly brackets. Age is also a placeholder here, and I live in city. And as you can see here, we have a white space after the city, and we see that here as well. It's kind of the annoying thing with paste. It always adds white spaces before sticking things together. You can avoid it by using paste 0, but then you have to add the white spaces manually where you want them, and that's annoying. And with glue, you simply see things as they are, and then you just use these little placeholders here, and then things work out much nicer. This kind of syntax is especially useful when working with databases and using SQL code with that. If you're assembling SQL code from R using these string concatenations, then you want to make sure that you use glue. Not only is it more convenient, it's also safer because it saves you from the risk of SQL injection. It's one of the most common security vulnerabilities, so we should avoid that at all costs. To show you what I mean, I have an example. Let's use a table name customers and the minimum age 25. And then with paste, you could stick things together like so, and then you'd have a SQL query. But assembling SQL queries like that can be very tedious, very fast. And again, it's not safe against SQL injection because there is no checking of what is actually an ID or so. So that's why we can use the glue package to assemble SQL code. For that, we first need a database connection that we can create using the dbconnect function. And then we can use the glue SQL function to assemble the SQL code. And there is where we need the connection, because depending on what kind of connection it is, what kind of database you connect to, the SQL dialect might be different. And glue SQL takes care of using the right dialect. So if you execute this here, you see that you have a SQL code now. One thing you'll have to be careful about is to wrap variable names that you want to use as IDs, for example, as an ID for a specific table that you want to use. You'll have to wrap this into these backticks. But once you know that, it's really easy to use. And an even nicer thing is that this function flattens vectors for you. For example, if you have a vector called calls, and in there you have the column customer and price that you want to access. You could use your query from before, but now instead of selecting all the columns, you could say, okay, give me the columns here. They are supposed to be used as IDs. So let's wrap them into backticks. And if you do that, you now have two SQL queries, which is probably not what you want. Instead, you want to have it collapsed into one. And there is where you can use this asterisk symbol to put things together. Nice. So with that, we have learned one more trick. I want to show you even more cool tricks. But first, let me mention that if you enjoy this video, then make sure to hit the like button so that I know that you actually enjoy this video. And more importantly, the YouTube algorithm also knows that. So not a lot of stuff you have to do to show me that you appreciate this kind of content. But to me, it really helps a lot. So thank you for that. And now let's get back to the video. Even though we do mainly data science, it can be really convenient to use HTML and CSS. For example, in tables, when you want to create a custom table using GT or Flex table, this is where you often need some HTML and CSS. And it can be easy to think, I'll just assemble my HTML and CSS using string concatenations. I'll quickly wrap things together. And this is what we have in this code example here. Here we have created HTML. And if we write this into the cat function, then we actually see it printed more nicely. So it does the job, but this way of writing code is really tedious and it will get very hard very fast. So instead of doing that, you should probably use the HTML tools package. It comes with lots of functions that are named like the tags that we use here. For example, there's the span tag that we've used, and we can use the span function. We can specify a style using the CSS function from that package. And then we can say the color, it is supposed to be what we have in my color here. And we want to have the span tag filled with text. We can simply stick this in here. And that way we have much simpler code and much easier to maintain code that does exactly the same thing. And if we want to have this as a character later on, we could also make this into a character using as character, because sometimes functions that you want to stick the HTML and CSS into, they want you to pass this into as character before. So this kind of assembling HTML and CSS can be really useful for things like table visualizations, or you could also use this sometimes in ggplot, but I don't want to dive into those details here. But what I do want to talk about regarding visualizations is duplicate code inside of ggplot. For example, here is a little ggplot example that creates a plot like this. It simply takes this empty cars data set and prints the names of the corresponding cars into this grid here. And it does so using two distinct styles for the labels. In one case, it uses left alignment, bold text and red color, whereas in the other setting it uses just right alignment, regular text and regular color. And I used to think that the only way to create such a different kind of setting is to duplicate the GM layers and then use differently filtered data sets inside of these layers. But this just duplicates your layers, and while there is a place for this kind of technique, sometimes you actually want to do that. In a scenario like this, you actually want to avoid this because it simply duplicates your code. A better way to do that is to simply calculate these values depending on the filter condition. So let's create a new data set where we just take a regular data set and create a bunch of new columns. Let's also make this into a table for nicer formatting. Then we see that we have a bunch of new columns here, and we have calculated them using if-else. Actually, we should use the same if-else function here with an underscore. And here's where we've simply stated the different color settings or the different font face settings or the different HJust values depending on our filtering condition. So basically the stuff that we have specified here and there, but in this data set we have it all in one. So with that we could take the data set, pass it to ggplot, and then simply take one of the GM text layers. We don't need to specify the data argument anymore. For the label we can simply use the car name that we have calculated here. And then for the hard-coded HJust font face and color values, we don't want to ggplot to map it depending on its own logic, but instead it should just grab the values from this data set. So we'll just take this data set and access the corresponding columns. So if we do that and then re-execute this whole code here, then we see that we get the exact same image, but with less ggplot code. Now you might argue that, okay, this isn't actually less code because we now have more code here, but it actually is two separate sets of code. One is for data wrangling and one is for plotting only. And this kind of separates out the concerns. And when you later revisit this code, then you don't have to figure out where did I do what. You simply look either into the data wrangling or into the plotting part. This is how this different kind of logic helps you there. Next, let us move on to 2 tips on working with Quarto. And for this, I brought you a little Quarto file here that has only one code chunk in it that defines one function, then another function, and then it processes the data. So if you render this, then you'll get an output like this. And actually, we forgot to use one function. Let's also calculate this summary here and re-render this. And then we have the output that we actually wanted to see here. So we could also get rid of this code sourcing here, or at least in the output. Let's do echo this false, and then we only get the output here. So on one hand, this works. We have defined our helper functions inside this Quarto file, and then we used it and we generated some output that we show inside of Quarto. That is nice, but it isn't necessarily nice to maintain. Here I have one long code chunk that does way too many things. I mean, one part of this comes from these functions doing way too many things probably, but still it isn't nice to having to scroll up and down to figure where was each function defined. And a very simple way to make your life nicer there, or to make your life easier there, is to simply stick these things into separate files. And I've done so. If we look into my Explorer here, you'll see that I have inside of my R directory 2 scripts called calculate summary R, where I define the one function, And I also have this other script that is called process data R, where I define the other function. So I don't actually need to use these functions in here. Instead, I can simply source these R script files. So if I stick in these two source commands and then re-execute our code, we see that our output is exactly the same, but our code is much easier to work with. So this was tip number 1 that was related to Quarto. Let's talk about tip number 2. In Quarto, it is really nice that you can have some values defined. Let's call it values. And let's do numbers 10, 20, 30. And then we could use these values inside of plain text. So we could write just regular text, the value is, and then we could use some R code to access values and then access one thing. And then we could actually duplicate this and access different values. And that way we'd see that, okay, we have some nice text output here. And this technique can be used for all kinds of other purposes where you want to display different things inside of your Quarto file, but the code that generates that isn't necessarily nice to work with. Imagine you have repeated this over and over again, like 20 times, and then you realize, oh, maybe I want to change the template here, and then you have to update all of these 20 instances of this template. That's not particularly nice, but thankfully we can do better. Namely, what we can do is to create a code chunk and just iterate over the values here. So for val in values, inside of glue, we do the value is val. So now if we execute this, we see that we don't really have an output right now, but let's make sure that we actually print this. And now we see that we have this code here. Actually, I have written values incorrectly, but this isn't formatted nicely. But since all of this is HTML and CSS under the hood, we can use the HTML tools package to generate paragraphs here. So let's use from the HTML tools package the p function to generate a paragraph. And now let's re-render this. And now we see that, okay, it cannot find the function p because we haven't actually loaded HTML tools inside of this Quarto file. So now that this works, we see that cat doesn't like the output of this p function. And this is where we come back to where I said sometimes you need to make this into a character first. So let's make this into character. And now let's re-render this. And now we see that, okay, now we have formatted HTML code, but we actually see the code itself instead of the output. But what we can do inside of Quarto code chunks is to specify that the output is supposed to be taken as is. And that way everything is rendered more nicely. And this kind of technique seems really mundane here and feels overblown to go from the glue command that already mostly did what we wanted to do and make this into HTML here. But this technique allows you to do all of the styling that you might want to apply or code or like text structuring that you might want to do with this. So this technique can bring you a long way, and I really enjoy creating parameterized reports using these techniques. That's what I often do when I work with clients and I create parameterized reports on different subsets of data. This technique comes in really handy to repeat the same structure of the document, but use these little data placeholders inside of the text. Nice. With that, we have covered a whole bunch of code improvements. I hope you enjoyed this video. Let me know in the comments which one was your favorite tip. Let me also know if I forgot something important. I'm sure that I could also make this list much longer and have a whole bunch of cool tricks in there. So feel free to chime in with your tips. And now with all of that said, I say thank you for watching and I'll see you next time.